2.6. There's only 3 of them here, and that's 7. On 2.6, number 7 says a right triangle has one corner, a rectangle has one corner on the quadrant 1 on the graph of 16 minus x squared. So let's draw that real quickly. That's an upside down parabola that's up 16. So 2, 4, 6, 8, 10, 12, 14, 16. And if I go over 2, I would go down 4. 2, 4 would be here. If I go over 4, it would be 4 squared root of 16 to be down to here. So it's a parabola that looks like this. Oh, over 2. And over 4, which would be right here. If I go over 1, it's down over 2. I did 2, 4, 6, 8. So 4 here, right there. There's 4. There's 2. There's 2. There's 16. So that's what it looks like. And we have a rectangle, has a corner in quadrant 1. Quadrant 1 is here. Uses the axis, and it has a point on the graph, P. And so the point on the graph is x and y, which is 16 minus x squared. So to this point I have to go over x and up 16 minus x squared, and we're supposed to express the area of a rectangle as a function of x. So it's going to be area is width, well it's x out to that point, times height, which is 16 minus x squared. That's A. B, what's the domain? Well, this only makes sense to talk about this for x going from 0 to 4. So the domain is from 0 to 4, and it could be 0 or 4, but the rectangle just disappears. And graph this area. So I will just do that with my graphing calculator. It's going to be x parenthesis 16 minus x squared close parenthesis. If I go zoom 6, and it says find for what value is the area largest. Well, it looks like it's the highest somewhere in there, so I need to look higher. So I'm going to go up to 30, and now I'll graph it. And it's somewhere around 2 to 3, so I'm going to go look for the maximum. Second, calculate the maximum between 0 and 4. Between 0 and 4, and my guess is about 2. And it says the maximum is actually 24.633, and it happens at x equal 2.309 something. Approximately 2.3. So for what value of x is the largest? About 2.3. That's 7. 10. 10 says we have a circle in a square. And the circle has a radius of r, and it says express the area of the square as a function of the radius of the circle. The square. Well, the square is base times height, but if this is the radius, then this is the radius and that's the radius, so this side has to be 2 radiuses wide and it has to be 2 radiuses tall. So the area of the square as a function of r is 2r times 2r. So there's part A. Express the perimeter of the square as a function of r. The perimeter of the square, well, that would be this length plus this length plus this length plus this length. So the perimeter of the square as a function of r is 2r plus 2r plus 2r times 4. And that's number 10. And then 21. 21 says, we have, we did this one in class. We have a cone and we have a cylinder in the cone. And the cylinder has a height of little h, and it can go up or down, and that'll make the radius of the cylinder get smaller or larger. The cone has a radius of capital R and a height of capital H. And it says, express the volume of the cylinder, which is pi little r squared h, as a function of only r. Well, we have an h in it. So we have to get the h out of here, the little h. Now, big H is a fixed cone and a big R, so as I said in class, there's some special triangles here. There's a triangle there, a triangle there, and a triangle there that are all similar. So if I use the big one, that's the height of the big cone to the radius of the big cone. That's a constant, that's a number. That's supposed to be non-changing, but it matches, depends on where you put this point, it would still have this height and this radius. Well, this height is the big height minus the height of the cylinder over the little r. Or if we use this triangle, it's going to have a height that's little h, and over a radius that's big R minus little r. And we have to replace, if we're going to make this a function of r, we got to get h out of there. Well, we can solve for little h in this, forget this piece, by multiplying both sides of this by r, big R minus r. Over here and over here, it would cancel here, and so we would get h equal to capital H times big R minus r over r. That's multiplying both of this and this by r minus r. Big R minus little r. Big R minus little r, and they cancel. So that's what I put in for h here, and so I finally get my volume as a function of r as pi r squared. We can leave that. We're replacing this h with capital H, capital R minus r over capital R.